Hello everyone, I am Anusha of 8th SEM from Computer Science Department, and today I am here to present my technical seminar on the topic Edge Computing under the guidance of Roshan sir. Here are the list of contents. Let's begin with abstract. First, let us know what is cloud computing. Cloud computing is the on-demand availability of computer system resources. People generally use cloud in order to store and use the data, but here the cloud is limited in some areas like latency, bandwidth, security, and offline access. These are the main problems of the cloud. In order to overcome these four problems, users need a secure infrastructure, which is called the edge computing. Here, the word edge refers to distribution. In order to improve the reliability and faster response time, combine both the cloud and the edge infrastructures. When the data is physically located closer to the users who connect to it, information can be shared quickly and securely. In financial services, gaming, healthcare, and retail, low level of latency are vital for a great digital expertise. Next comes the introduction. As you all know that technologies are growing too fast in the world, the smart cities, agriculture, cars, and the health in the future require a huge deployment of IoT sensors, where all the edge computing will drive these implementations. Let us know what is exactly the edge computing. Edge computing is a technology that is possible to process the large volume of data generated by the devices connected to it, the internet through the IoT. Here, the rapid increase and the success of rich cloud services have pushed the origin of new computing paradigm called the edge computing. In simpler words, it means the processing of data. Edge computing has a potential to address the concerns of response time requirement, battery time constraint, bandwidth cost, and saving the data privacy and the safety. In simpler words, the edge computing can be told running fewer processes in the cloud and moving those processes to the local places such as PCs and the IoT device. Data which is produced by the IoT devices to be processed where it is created instead of taking away to the roots. Next comes the objective. The two main challenges of the cloud computing was the high latency and data privacy. In order to solve these two challenges, the edge computing main objective is to minimize the need for long distance communications between the client and the server, which reduces the latency and the bandwidth usage. Edge computing optimizes the internet devices and the web applications by bringing computing closer to the source of the data. Edge computing can provide a new functionality that wasn't previously available. This sentence means, let us consider an example to understand this sentence. A company can use edge computing in order to process and analyze the data at the edge, which make to do all the possible operations on the real-time environment. Here, the two figures at the end represents the cloud data and the user, and the intermediate the edge gateway server. It is used to provide the low latency. Here, the word latency means it is a time that takes to process a request to go from client to the server and return back the request to the client. Next comes the system architecture. The edge computing architecture includes four parts. One is core infrastructure, edge servers, edge network, and the last one is edge devices. Let's begin with core infrastructure. It includes the cloud platform and its services. It provides the data warehousing. It means where the large amount of data can be stored, so it is called as warehousing. It also performs the big data processing and the business logic. Next comes the edge server. An edge server is a server that resides between two networks called the private network and the internet. It involves the real-time data processing, data filtration, and optimization functions. Edge servers can serve different purposes depending on the context. Next comes the edge network. It is a network that is located on the periphery of centralized network. The LAN are considered as edge networks. The edge networks feeds the central or core network. The network provided by the CNS content delivery service provides the duplicate internet connected to the many servers across the world. The last one is edge devices. It includes the sensors, controllers, mobiles, healthcare, and TV or the cars. An edge server is a device which provides an entry point to the service provider core networks. Next is the three-tier model. The typical three-tier model consists of three tiers. First one is IoT tier, second is edge, and last one is cloud. The first tier is the IoT, which includes the drones, sensors, is connected to the health area, devices and applications in the smartphone and equipment in industrial internet. The second tier, edge, includes the cellular network, gateways, edge server. We have discussed what is edge server in the previous slides. It resides at two networks called private and the internet. IoT tier and the edge are interconnected with the communications that is made by 3G, 4G and 5G with the help of Wi-Fi and Ethernet. Multiple communication protocols are used to connect the IoT and second tier edge. The protocols between the IoT and the edge usually have the characteristics of low power consumption and the short distance, while the protocols between the edge and the cloud have large throughput and high distance. The Ethernet, optical fibers and the coming 5Gs are performed communication protocols between the edge and the computing cloud. The last tier cloud consists of three platforms called Google Cloud, AWS and the Microsoft Azure. The second tier edge and the cloud can be connected to the Ethernet optical fiber. Now let us discuss the last tier cloud platforms. The first, called Google Cloud, is a platform that provides computing resources for deploying and operating applications on the web. AWS, called the Amazon Web Servers, offer reliable, scalable and inexpensive cloud services. And the last one is Azure. Azure is a public cloud computing platform. Next comes the characteristics of edge computing. The key characteristics of edge computing are: first is geographically distributed. It means the services and the applications of the edge is widely distributed. They are scalable, autonomous and distributed. Edge computing is contextual and low latency. It means the support at the endpoints with the finite services at the edge points, where the first services at the edge of the network. Real-time interactions. It involves the real-time interactions made in the environment for the speedy services. And the last of the edge computing is characteristics is heterogeneous. It is the edge nodes can be deployed in a wide variety of environments. Next comes the benefits of edge computing. The above figure here represents the 5 key benefits which plays a very important role in order to be the objective of the edge computing. First one is security. Security. No theft during transport. It means there will be no theft during the transport. There will be no leakage of informations which are made between the connecting servers. They are locally stored. Compliance is maintained. They are locally stored, meaning is since more data is being processed on local devices rather than transmitting it back to the central data center. Next comes the speed. As you all know, in many companies, speed plays a vital role in the core business. Here, the latency is measured in microseconds rather than the milliseconds. It's operating at the source of the data. Faster responsible time. Next comes the scalability. Here, no need to transport everything information to the cloud. It has no recurring cost. It means the edge also empowers IoT devices to gather data rather than waiting for the people to log in without devices and interact with the cloud services. Edge computing are always connected on throughout the world. Next comes the reliability. It can offer connectivity without the edge by processing data closer to the source. Data can be unrouted through the multiple paths, can work without connectivity. And the last one is cost saving. It means the less expense. Next comes the applications. First is traffic management. Due to the computational inexpensive and expensive complexities of traffic management efficiency, one of the best way to optimize traffic management system is by improving all the performance to perform on real-time data. Here, intelligent transportation system makes extensive use of edge computing technologies, especially for traffic management process. The traffic management process involves the TSP problem. It means traveling salesman problem. As you all know, we have discussed in data that the traveling salesman problem, it is used to find the shortest distance and shortest routes. Edge processing saves on network expenses, storage and operating cost for the traffic management solutions. Next is the smart cities. The rising number of autonomous vehicles, ever growing of smart cities, IoT and live benefits, cloud computing applications fail, where edge computing applications depend upon the gadget collecting information to do fundamental processing tasks. The city of coming vehicles will ability to respond progressively of changing conditions as it happen. It means all the world can be connected here based upon the sensors, storage, security, and your home will become the more smarter when all the applications will strongly respond system. Next comes the autonomous vehicles. Edge and the distributed computing technologies increase safety, spatial awareness, and current generation hardware. Vehicles can exchange real-time sensor data and improve decisions with less onboard resources. Where mobile edge computing, vehicles can exchange all the real-time sensory data. The next is video conferencing. There will be a poor video quality, frozen screens, a slow link to the cloud can cause a many video conferencing frustrations, and it became a main problem in order to communicate. By placing the server at the edge of the video conferencing software closer to the participants, quality problems can be reduced. Here the edge plays a very important role. And the last one is healthcare. In order to increase the performance and responsiveness of healthcare plays a vital role in order to solve the patient's problems. Next is the future scope. The future of edge computing is not only IoT, it is also used in many networks. A CDN usually uses a nodes closer to the users to pre-patch and catch web content. These edge nodes can be performed some content customization such as addition, location, relevant, advertising, and more importantly, CDN saves bandwidth and caching. Video streaming. It refers to an exciting cloud network advancement that can lower the latency for live stream of video and cloud gaming. These are the fastest growing high bandwidth applications. Last one is it is used in advanced drones. It makes use of flexible on-board GPUs. It uses 5G that provides ultra bandwidth. And the last one is conclusion. The growing number of sensors, connected machines, geographic heterogeneity for the data store, requests for real-time response have rise of edge computing. The heterogeneity means edge nodes can be deployed in a wide variety of environments. Here, the edge computing was established in order to make the low latency and data security, which plays a very important role in speeding and the business. Here are the some references. Thank you.